Okay, I'm having a look at a question from Unit 4 and looking at how we can do that on our calculator. So this one I'm looking at how we can determine if we have a probability density function and how we can use our calculator for that. So when we are checking it, we would be doing the integral of sine x between negative infinity and positive infinity, but in this question we have been told to go between between 0 and pi on 2 was the domain given. Now we could do this algebraically, but we can use our calculator to do this. So what I can do is go into my y equals, I can put in the sine x there, and I can graph that. Now I've got my calculator in degrees, so I'm going to quickly change that to radians. And so now when I graph it, I can see that sine curve. If I wanted to stay in degrees, I would have had to change my window to go between 0 and 360, or 0 and 90, because my pi on 2 is 90. I need to be able to show that on my screen. Here I've got my pi on 2, so I can use that in radians, and I've got it in radian mode there. So I'm going to use second trace 7, and I'm going to tell it to look between 0 and pi on 2. And so then it will shade that section in, and it tells me that that area is equal to 1. So I know that it is a probability density function. Then when I want to do the e of x, I know that I have to put the x in front of that function. And I'm going between 0 and pi on 2 again. So I'm going to go back to that equation. I'm going to put in an x in front of that. Press graph again. And then I'm going to do my second trace 7, and I'm going to go between 0 and pi on 2. And again, it does equal 1, which happens to be also equal to 1 for that as well. So that can be a quick way of working out your integrals like for your definite integrals, if you're working out probabilities from a function like that.